Hi ladies, this is lesson 5.6 for geometry. It's about proving quadrilateral properties. So in this chapter, we're going to practice with our deductive reasoning, and we're going to do that using flowchart proofs, or at least some supporting evidence of the conclusions that we draw. So whether it be flowcharts or bulleted lists with supporting evidence in your conclusions. So we have a couple key vocab terms for this lesson. The first one is dart. And so already we've worked with convex polygons, especially quadrilaterals in this lesson. So we've worked with rectangles and squares and kites and rhombuses, but a dart has similar properties to a kite, but it's a concave polygon. And so on your note sheet, you can see actually an image of a dart. And then the second key vocab term that we have is called backwards planning. And this is just a method that we're going to use as we start to lay out our proofs. So in backwards planning, you start with the desired end result and use logic to reason back into the given information. So you're going to start with the end, hence the name backwards planning. And this can be a strategy that you use not just for obviously geometry, but anytime you're trying to plan something out. Even like if you think about your goals, think about where you want to be and then what kind of steps do you have to do to get there, and work backwards. Okay, so in this example, we're going to look at this dart AD, BC. So again, this has the same properties of a kite in that it has two pairs of consecutive congruent sides, but it's concave. It's not a convex polygon like the other kites that we've been working with. So if you look at this diagram, first what you want to do is mark what you know. So here in the given information, it tells us that it's a dart, AD, BC, which means we already know that it has two pairs of consecutive congruent sides. But here it tells us what sides those are. So AC is congruent to BC, and AD is congruent to BD. So mark your diagram. And we want to show that CD bisects ACB. So we're looking to show that this segment bisects this angle. Okay, so that's our goal. So to start, you want to start with the conclusion and reason back to the given. So if the conclusion is CD bisects angle ACB, how are we going to show that? We can show that CD bisects ACB if we can show that those two angles are congruent. Okay, so can we show that this angle is congruent to that angle? Okay, maybe, but not yet. With this given information, if you look at that, there's no way to tell. I mean, you can use your protractor and measure, but that's not how you do a proof or like a deductive reasoning. So if ACD, I can show that those two are congruent if I can show the triangles are congruent. So if you look at this, we've got two triangles here. Well, ADC and BDC would be corresponding parts of those triangles. So can I show those two triangles are congruent? Well, maybe, not yet. I can't show it yet because all I have right now is a side-side angle, and side-side angle is not a shortcut. for triangle congruence. So those two angles are going to be congruent if triangle ACD is going to be congruent to triangle BCD. Alright, now, how do I show those triangles are congruent? Well, I need to show one of the shortcuts. So I need either side, side, side. I need side, angle, side. Angle, side, angle. Or angle, angle, side. So if I can show any of these are true about the two triangles, I can show triangles are congruent. So if I can show one of these, I can show the triangles are congruent. So let's look and see what we have. We have one angle and we have two sides. Is there one of these congruent shortcuts that's going to be easier to prove than the other? Probably the side, side, side is going to be the quickest to prove. So side, 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 in order to prove the triangles are congruent, so I can show the triangle ACD is congruent to triangle BCD if I can show side, side, side. All right, and then I can show side, side, side if I can show that this third side is congruent to this third side, which it is. If I can show that CD is congruent to CD. Can I do that? Yeah, that's going to be a pretty easy one to prove because it's a shared side in both triangles. So looking at the next part of your note sheet, and I've set up this flowchart for you, but at some point you should be able to set up your own flowcharts. So let's start with that table that we just filled out. And let's start from the end, like we did in our table. So the last thing that we want to do, our proof says show CD bisects ACD. Okay, so that's what's going to go in the last box, because you always have to end with your conclusion. Okay, so now how do we get there? And actually, maybe we should have filled out one more box on our table. Okay, so I can show that those two sides are congruent, but actually, how does that help me prove that we have an angle bisector? Well, if we have an angle bisector, these two are going to be congruent, and if the triangles are congruent, so I can show that ACD or I can show that the angles are congruent. Angle, that should be angle. ADC is congruent to angle BCD because of corresponding parts of congruent triangles. So because these two triangles are congruent, those angles have to be congruent. And if those angles are congruent, then I know that CD is an angle bisector. So using your table that you created, fill out this flowchart. Remember, you have to state the given, and you have to end with your conclusion. Okay, so our conclusion is that CD bisects triangle ACB, but how do we actually get there? Well, we've got a couple of givens. AC is congruent to BC. And AD is congruent to BD. Given. And then lastly, we wanted to show that the triangles were congruent. So the third piece that supports those triangles are congruent is that CD is congruent to CD because it's a shared side. Okay, so then next we use side, side, side to conclude that ACD is congruent to BCD. And then if those two triangles were congruent, an angle ACD is congruent to BCD because of corresponding parts of congruent triangles. And then lastly, we know that CD bisects ACB because that's what the definition of a bisector is. It splits two angles, it splits one angle into two congruent angles. Right, then your next example is to draw and label a diagram that would be useful in setting up a proof in this given. So read through the whole thing first. And sometimes it's helpful to start with the last thing. So you know that you have a quadrilateral, but you know that you have angle D equal to 90 degrees. So let's do that first. D is equal to 90 degrees. And we know that AB and DC are parallel. So here's AB, here's DC, those are parallel. And we know that AD and BC are congruent. So again, it's often useful to start with the end, but it's very important to read the whole thing first. So then the question is, what conjecture do you think you can prove? Well, you can probably try to prove a number of things. First of all, maybe that angle C equals 90 degrees. You might try to prove that AB is congruent to DC. You might be able to prove that this is a rectangle. Or that AD is parallel to BC, that it's maybe a parallelogram. So there's a number of different things that you could potentially prove, but start with your diagram. And then this last question, just to kind of get you thinking about where to start. It says Shanika is planning her proof that triangle WXA is congruent to ZYA, so look at this diagram. And she knows that WXA is congruent to ZYA. So WXA is congruent to ZYA, so she has those two angles congruent. What other information does she need to prove the two triangles are congruent using angle side angle? Well, if you just look at what else you know here, you know that these two angles are congruent because they're vertical angles. So we need angle side angle. That means we need XA is congruent to YA. So angle XWA, if you look here, XWA is congruent to YA Z. That's not going to help us at all. So it's not going to be that first one. Angle or side XW is congruent to side YZ. Well, that's side angle angle, which it's a shortcut, but it's not angle side angle. So it's not B. WA is congruent to ZA. WA is congruent to ZA. Again, angle, angle, side. That's not what we want, so it's not C. And then XA is congruent to YA. This is the one we want. Okay, so make sure that you read again through the whole question, and then use your diagram to mark the information that you know. So if you have any questions, please jot them down and we'll discuss them next time I see you in class. Thank you.